Have you ever wondered why an airplane is designed so uniquely, just so we can fly through the sky smoothly? The reason it's designed like that is because there's a force called air resistance, which also has a big impact on our daily lives. In this video, we'll introduce you to air resistance by its definition, factors affecting it, and its application in daily lives. So you may ask, what on earth is air resistance? Air resistance is the force that opposes an object's movement as it moves through the air, which is caused by friction between air molecules and the object's surface. There are many factors affecting air resistance. Have you ever wondered why airplanes fly differently in hot and cold weather? It turns out weather plays a huge role in air resistance. For an airplane, air resistance is the motion that acts against the aircraft as it moves through the air. When the temperature is high, the air molecules in the atmosphere move faster and spread out more. This makes the air less dense, which means there's less air resistance for the airplane to overcome. Conversely, when the temperature is low, the air molecules in the atmosphere move slower and are closer together, making the air denser. This means there's more air resistance for the airplane to overcome. The temperature of the air affects air resistance because it affects the density of the air. So, when an airplane is flying in hot weather, it experiences less air resistance than in cold weather. Have you ever wondered why airplanes fly differently on humid days and dry days? It turns out humidity can impact air resistance. When the humidity is high, there's more moisture in the air, which can make the air more dense and increase air resistance for the plane. Conversely, when the humidity is low, there is less moisture in the air, which can make the air less dense and decrease air resistance for the plane. The humidity of the air affects air resistance because it affects the density of the air that the plane is flying through. Weather can also affect humidity and air resistance. When a plane flies through a storm or turbulent weather, the humidity levels can change suddenly, which can affect the plane's performance and speed. Weather can be a factor of air resistance because it can affect the humidity levels and in turn the density of the air that the plane is flying through. So the next time you're flying on a plane and wondering why it's flying differently on a humid day, remember that humidity can impact air resistance, which can affect the efficiency and the performance of the plane.
Have you ever wondered why cyclists use aerodynamic equipment and clothing? It turns out total surface area plays a big role in air resistance. For a cyclist, air resistance is the force that acts against the motion of the bicycle as it moves through the air. When a cyclist is riding with a large backpack or carrying bulky items, it creates more total surface area, which means there's more air resistance for the cyclist to overcome. Conversely, when a cyclist uses trim-lit equipment and clothing, it reduces the total surface area of the cyclist, which means there's less air resistance for a cyclist to overcome. The total surface area of an object affects air resistance because it affects the amount of air that the object has to push out of the way as it moves through the air. Wind can also affect air resistance. When a cyclist rides into a headwind, the air resistance increases, making it harder for the cyclist to move forward. But when they ride with a tailwind, the air resistance decreases, making it easier for the cyclist to move forward. Wind can be a factor in air resistance because it can add or subtract from the speed of the cyclist relative to the air around it. So, the next time you're cycling and trying to improve your performance, remember that the total surface area affects the air resistance, which in turn affects the speed and effort required to move forward. Choosing trim-lit equipment and clothing can help reduce air resistance and improve your overall efficiency.
Have you ever wondered why cars have different fuel efficiencies at different speeds? It turns out velocity plays a big role in air resistance. Air resistance is a force that opposes the motion of an object through air. It is affected by several factors, including the shape of the object, the speed in which it's moving at, and the density of the air. For a car, air resistance is a force that acts against the motion of the vehicle as it moves through the air. When a car is driving at high speeds, it creates more air resistance, which means the engine has to work harder to maintain the same velocity. Conversely, when a car is driving at low speeds, it creates less air resistance, which means the engine can work more efficiently to maintain the same velocity. The velocity of an object affects air resistance because it affects the amount of air that the object has to push out of the way as it moves through the air. Wind can also affect air resistance. When a car drives into a headwind, the air resistance increases, making it harder for the car to maintain its velocity. But when it drives with a tailwind, the air resistance decreases, making it easier for the car to maintain the same velocity. Wind can be a factor in air resistance because it can add to or subtract from the speed of the object relative to the air around it. So, next time when you're driving and trying to improve your fuel efficiency, remember that an object's velocity affects air resistance, which in turn affects the efficiency of the engine. Driving at lower speeds can reduce air resistance and improve fuel efficiency, while driving at higher speeds can increase air resistance and decrease fuel efficiency.
The myth of mass and air resistance. Have you ever heard the myth that heavier objects experience more air resistance than lighter objects? It turns out there is no connection between mass and air resistance. The mass of an object doesn't affect air resistance. Two objects with different masses will experience the same amount of air resistance if they have the same shape and are moving at the same speed through the same density of air. An example of this is a feather and bowling ball falling through the air. Even though the bowling ball has a greater mass than the feather, they both experience the same amount of air resistance as they fall through the air. For a car, air resistance is affected by the shape of the car, the speed at which it is moving, and the density of the air. The mass of the car doesn't impact air resistance. However, a heavier car may require a larger engine to maintain the same speed as a lighter car, which can impact fuel efficiency. So, the next time you hear the myth about mass and air resistance, remember that it's not true. Air resistance is affected by an object's shape, speed, and the density of the air, not its mass.
Air resistance, also known as drag, is the force acting in the opposite direction of the motion of an object during fluid, such as air. It is caused by friction between an object and the air, which generates a pressure difference that slows down the object's motion. The amount of air resistance depends on several factors, such as the shape and the size of an object, the speed at which it's moving, and the density and the velocity of the fluid. To calculate air resistance, scientists and engineers use a mathematical formula called the drag equation, which is expressed by 0.5 times speed times velocity to the power of 2 times cd times a. The first term in the formula, which is P, represents the dynamic pressure of the fluid acting on the object, which increases the square of the velocity. The air resistance formula is used to predict the amount of air resistance an object will experience under various conditions. The density of the fluid P is affected by temperature, pressure, and humidity, while the drag coefficient of the object CD is determined experimentally through the wind tunnel testing. The cross-section area of the object perpendicular to the flow direction, A, is also affected by the size and the shape of the object and is a measure of the amount of fluid that the object has to push out of its way as it moves through the fluid. This information is used to design and optimize vehicles, buildings, and other structures for efficient movement through fluids, and to understand the effects of air resistance on sports performance. By reducing air resistance through streamlined shapes and other techniques, athletes can improve their speed and efficiency.
At last, we'll enjoy a short video to summarize all the things we've learned.
Hi guys. You know, sometimes in science we describe things according to properties, and properties are when you describe things according to their color, their shape, their texture, their size. Like a property of me is I'm extremely beautiful and handsome, right? Okay, maybe not, but check this out. Here I have two sheets of paper, right? Now if you look at them, they're exactly the same. Same color, same shape, put them together, same size, hold them side by side, they're exactly the same weight. But now I'm going to change a property just on one of them. I'm going to take this piece of paper and I'm going to crumble it as hard as I can. Just going to squeeze it and squeeze it and squeeze it and make a very, very, very tight ball of paper. Now, if you look at these two sheets of paper, okay, and I asked you a question, I guarantee you're all going to get this question wrong. Which one weighs more? Is it A or is it B? Now, most of you are going to say it's B. And actually, they're exactly the same. All I did was change its shape. I didn't change its weight. Think about it. If you weigh 50 pounds and you put your hands in the air, you still weigh 50 pounds. If you're jumping into a pool of water and you turn your body up really tight and you're doing a cannonball, you put all of that weight into a small space, but you still weigh 50 pounds. The weight didn't change. I changed the shape. Now, I have a cool little fun story I like doing with these papers. I'm a little weird, but let's just pretend that these papers talked. And these papers lived in Paper Town. And all of a sudden you have this big guy walking and he's like, and you got this small little guy walking. He's like, hey, what are you doing? Nothing. Why don't you move out of my way? Do you know who you're talking to? Yeah, someone very big. What? And very ugly. Now, of course, these papers get into this huge conflict, and then they get into this competition. They're going to have a race. So they climb on top of a mountain. The loser has to leave town. And the race is this. This guy thinks because he's bigger, he's going to hit the floor faster. So they climb on top of the mountain. Okay? Now remember, the loser, okay, has to leave town. Now let me ask you a question. If I drop these two sheets of paper at exactly the same spot, I'm changing nothing. I'm not forcing them. I'm just going to let them go. And the only thing that's different is its shape. They're the same exact thing. And I let it go. Which one is going to hit the floor first? A or B? Make a prediction. And now let's see. 3, 2, 1. Was your prediction right? I think it was. The ball of paper did hit the ground first. Now, does anybody know why? Well, you see, this large sheet of paper, it was really unfair. Think about it. Underneath this large sheet of paper is what? There's air. The ball of paper had just a little bit of air underneath it to move out of the way. This large sheet of paper, as he was falling, was moving through the air like do-do-do-do, 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 where the ball of paper had just a little bit of air to move, and it kind of was like, woohoo, super fast. Now think about it, okay? That's what air resistance is. The air is resisting. There's resistance. So this paper has to move all of the air out of the way, and the bigger the surface, the more the air, the more resistance, the slower it falls. Now, as you saw, the large sheet of paper did move really slow. The ball of paper did move rather quickly. And you guys can do this experiment at home. Try really big sheets of paper. Try really small sheets of paper. And ultimately, you're going to realize that the object that moves super slow through the air is the object that is extremely air resistant. And the object that moves extremely fast through the air is the object that's not air resistant. So now you know a little bit about air resistance.